Okay, here we go. We are in the second lesson of chapter 1, and we are going to look more closely at domains. So we've got a sort in front of us, and it's asking us to pick which functions have a domain that goes from negative infinity to positive infinity, or which functions have a restricted domain. And so to kind of show you the difference, I'm going to pick one that has a restricted domain. Let's look at number 7. When I look at y equals 7 over x, I'm like, uh-oh. X can't be, what? What can't X be? X can't be 0. We can't have a 0, right? 7 divided by 0 is not a value. Some people say it's infinity, but okay, that's another discussion. But anyways, so we know X cannot be equal to 0. And last year, you probably wrote something like this. Domain is all reals. You use that in kind of R with the 2 lines, except for X not equal to 0, right? That's what we did in Algebra 2 Trig. But this year, we've got to write our domain a little bit differently. And we'll get to that in another slide or two. But just know that number 7, x cannot be equal to 0. So this has a restricted domain. So let's look at where there are no restrictions. When I look at number 1, is there anything that x cannot be? No, x can be anything it wants to be. Hence, the domain for a linear function is going to be from negative infinity to positive infinity. Same thing, so this is, we'll check all of our functions that have a domain of negative infinity to positive infinity. Linears do. Quadratics do. They have unrestricted domains. Their domains will always be negative infinity, positive infinity. Same thing with exponentials. X can be anything it wants to be, right? There's no like, uh-oh, x can't be equal to 0 because, right, 2 to the 0 would be 1. There'd be a value for y when x is equal to 0. Even number 4 is also linear. X can be anything it wants to be. So all those that we checked up, oh, and another one, y equals absolute value of x. Is there anything that we say, oh no, x can't be that? Nope. All the ones in green that we've checked off have unrestricted domains. They all have the domain of negative infinity to positive infinity. So we already looked at 7. Let's do the red for this. Here we know x cannot equal 0. So we have a restricted domain, and we're going to talk about how to write that in the next slide or two. And for 5, x cannot be just anything it wants, right? It can't be negative 3. Square root of negative 3 is not going to give us a real number for the value of y. So x can't equal not just negative 3. X can't equal negative numbers, right? And so that's going to have a restricted domain. So find the domain of each of the following functions. And so when we look at A, we recognize that's quadratic. But mainly we recognize there are no issues here. All right, so what kind of issues are we looking for? We're looking for either a square root sign. Okay, that's going to be an issue when we have an x underneath the square root sign. Or we're looking for an x that's in the denominator. If we don't see those two things, we're like, yes, this is an unrestricted domain. So when we're looking at this, and I said a quadratic, I didn't say that it's a cubic function. Regardless, there's no square roots, there's no x underneath the square root, and there's no x in the denominator. So you know what? We're going to say this is unrestricted domain. I'm going to switch. I'm going to do red anymore. Let's do purple. So the domain is going to be, so the domain once again represents the value, what the values of x can be. Anything from negative infinity to positive infinity, which basically means any negative number you can think of. Even negative 1,000,000, billion, trillion, that's not a number, but you get what I mean. All right, so now for B, we're like, uh-oh, we're going to have a restriction here. There's a problem when x is in the denominator. So let's stop and ask ourselves, what can the denominator not be? Well, x plus 2 cannot equal 0. That's going to be a problem, right? There's not going to be a value for y when x plus 2 is equal to 0. So let's go ahead and subtract that 2 from both sides, and we get, oh, x cannot equal to negative 2. All right, if x can't equal negative 2, and I'm going to go into the space of C, but that's okay. I'm going to do a number line. I love number lines. We'll see that I use number lines a lot in pre-calc just to visualize what our thinking is. So x can't equal negative 2. I'm going to put an open circle there to represent that x cannot be negative 2. Now, can x be anything else? Are there going to be any issues with 1 or 100 or negative 99? No. X can be anything else it wants to be. So I'm going to use the squiggly line with the arrow to represent that x can be anything but negative 2. Now, I have to write domain in interval notation. I can't do the big R, comma, x not equal to -2. So what I'm going to do is I'm going to start with what's the smallest that the domain can be? Well, it can be all the way over to -infinity, right? And then we're going to go from -infinity, so we're starting way over here, -infinity, we're going along, and all of a sudden we come to a screeching halt right here at -2. We stop at -2. Now, can we include -2 in our domain? Absolutely not. There's an issue there. So we're going to put parentheses there, because remember, parenthesis means I see you, you're a placeholder, but you're not really included. We use brackets when we're including. All right, so let's stop for a second and look at more interval notation rules, because I'm about to use a U or an upside down U. We need to understand what those mean. Once again, I'm going to go back to, math is a universal language, and that's why we have notation, because everyone in the world knows when doing math that a U represents or. So I don't have to write the word or in English and then have somebody across the world not understand what or is, right? And when you write an upside down U, we all know that that means and. Now, how I remember that, because it's important to have, goofy things to remember things, I look at the word and, I'm like, oh, I see that upside down U in the word and. That's the way I learned this way back a long, long time ago, and it stuck with me, so maybe that will help you. So here's the deal. We're not going to use and in this case. We're going to come back to this problem. We're going to remind ourselves, what does domain stand for? Domain stands for what values x can be. So x could either be from -infinity to -2, not including -2, or x could be, we're going to start again, we're going to, -2 is our placeholder, or it can be from -2 all the way to infinity, not including -2. So see how -2 is our placeholder here? Because even though the domain isn't including -2, it certainly is including -1.999999, right? It's placeholder, and it is including -2.0000001. So once again, x can only be in one or the other one of these groups. Either x is from -infinity to -2, not including either -infinity or -2, or x can be found in -2 to infinity. So there we go. That was our kind of our first new thing, I feel like, of everything we've done so far. That is pre-calc. All right, so let's go ahead and move C down. Let's see if I can, oh, they're all attached, aren't they? All right, so we're going to go ahead and look at what our issue is here. Our issue is that we have an x underneath the square root, and we know that whatever is underneath the square root has a limitation, right? Hey, can we take the square root of 0? Sure. Can we take the square root of 1? Sure. We just can't take the square root of anything that's less than 0. We can't have what's underneath the square root be negative. So we're going to put whatever's underneath the square root, and we're going to say, you know what? You've got to be greater than or equal to 0. That's our limitation. And so what we're going to do is we're going to go ahead and solve this. We're going to subtract 5 from both sides, and then, oops, a little algebra comes in here. Well, we're doing algebra, aren't we? But a little algebra comes in here to say, uh-oh, this negative, I got to get rid of it. Sometimes people divide both sides by -1. Sometimes people, I'm just going to multiply both sides by -1, whatever you decide to do. But I'm like, uh-oh, inequality, multiplying both sides by -1, I know what that does. It changes my inequality, it flips it around. And so -1 times -x is x, less than or equal to +5. Now, I'm not going to go straight to my domain from this inequality. I'm going to draw a number line. And for those students who know best, they will do so as well. I've watched my students like, I don't need that number line. Oh my gosh, the number line helps us every single time. Use it. All right, x is less than or equal to 5, and I wrote -5. All right, you got to quit talking and writing at the same time, which isn't possible while making a video. All right, it can be equal to 5, absolutely. So there's that circle that says it can equal 5, and it can be less than or equal to 5. Once I have this, then I have a visual, and I can write my domain. The very furthest left, that arrow says -infinity. We always use parentheses with -infinity. I'm coming from -infinity. I'm going this way. How much can I go? I stop at 5. Now, do I include 5 in my domain? Absolutely. There's no problem with 5. Let's go back up to our original problem. If I plug 5 in, for x right here, 5 minus 5 is 0, square root of 0 is 0. We are fine. So that's our domain. All right, if I went too fast for you, just back it up and watch it again. I think we've got another example. Oh, practice. All right, so let's do some practice. We see no issues here. If there are no x's in the denominator and no x's underneath the square root sign, we're like, yes, our domain is from negative infinity to positive infinity. All right. Okay, we've got issues here, right? And our issue is with the 4x minus 1. What can it not equal? It cannot equal 0. So we're going to go ahead and solve this not equal problem. We're going to add 1 to both sides, so 4x not equal to 1. I know that's weird, but it seems to work. X cannot equal 1/4. I'm going to turn that into a number line where I'm like, okay, 1/4 is my placeholder. X can be anything it wants to the left, anything it wants to the right. And when we write our domain, we are going to start from the left, as we always do. We realize that arrow goes on forever. We're starting with negative infinity. We come from negative infinity, and we have a screeching halt at 1/4. It's an open circle. We don't include it. Now, x can either be in this group from negative infinity to 1/4, or it can be from the group that starts with the placeholder of 1/4 and continues all the way to infinity. All right, let's try another one. These are fun. All right, issue, right? Square root of x plus 4. X plus 4 cannot, or has to be, greater than or equal to 0. We're going to subtract 4 from both sides, right? X has to be greater than or equal to negative 4. I'm going to look back at what we did before. Oh yeah, there was a negative in front of the x. I'm like, why do we have to switch that sign anyways? All right, so x is greater than or equal to negative 4. I go ahead, put my circle on my number line. Greater than or equal to goes this way. Once I have that visual, it's really easy for me to see that the lowest my x can be, the least number is negative 4. There's a closed circle that matches up with our bracket, and then we go on all the way to infinity. We always use parentheses for infinity. All right, so hopefully you're taking good notes, because sometimes people refuse to memorize, or first of all, take the notes, then memorize all the different notation stuff that we have going on. You have to do it. Otherwise, you're just going to keep getting confused over and over again. Just stop and memorize. All right, x squared minus 5x, what do we know? Man, it cannot equal 0. It's in the denominator. So let's go ahead and factor. Let's factor out an x. We know how to factor. We've already reminded ourselves of those things. So either x cannot equal to 0, either x cannot equal 0, or x cannot equal 5. And that makes sense, right? If we plug a 0 in, we get 0 in the denominator. If we plug a 5 in, we get what? 25 minus 25, which is 0. We're going to really need a number line for this. So we put an open circle for 0. That's a placeholder. An open circle for 5. But guess what? X can be anything it wants to be besides 0 and 5. So we can see from our number line, we're going to have 3 parts to our domain. We're going to have this first part. Let me switch. So we're going to have this first part that starts all the way over at negative infinity and then comes to a screeching halt at 0. 0 is not included. Open circles match with parentheses. Or x could be from 0, placeholder 0. Now, you understand what I mean by placeholder. It's holding a place because 0 is not allowed, but 0.0000001 is allowed, right? So that's just a placeholder. We're going from 0 all the way to 5. 5 is a placeholder. We're going to use parentheses. Or our domain is going to be from 5, not including 5, that's why we're using a bracket, all the way to infinity. So wow, that was a long domain to write. Our number line really, really helps. All right, let's see what else we've got. This is a tricky one. We've got 2 issues in one. Why don't we go ahead and look at the numerator first? We know that x plus 4 has to be greater than or equal to 0, right? Because it's underneath a square root sign. So we're going to go ahead and subtract negative 4, or first subtract 4 from both sides. And I'm going to start our number line. We're going to go ahead and build on it once we have the denominator. We know, for one thing, x is greater than or equal to negative 4. Actually, I'm not going to do my number line until I see what's going on with the denominator. What is going on with the denominator? Let's look. With x plus 4, what can it not equal? it cannot equal 0. So that means x cannot equal -4. So when you put these two things together, that x is greater than or equal to -4, you also know x cannot equal -4. So we're going to start our number line with a -4. That's going to be our placeholder. So we're done with the second part of our restricted domain. We're going to look at the first part that says x is greater than or equal to -4. We already know, nope, sorry, can't be equal, but it's definitely greater than. So once we put those two things together, which, yes, has been our toughest domain problem so far, we've got a number line, and we can clearly see that our domain starts at -4, not including it. That open circle says we're not including -4, so we're using a parenthesis, and it goes all the way to infinity. All right, I think that was our last one. Let's see. Yes, we did it. Congrats. And please make sure you took good notes and you memorize the different rules for notation. That's super, super important. All right, see you next time.